So, the first thing I want to talk about is, if you haven't heard, I found this out recently. Actually, I'm going to paste this here. And I'll talk a little bit about, I was looking into why this is. So this is React's repo on GitHub. Oh, I'm in the wrong. And something that is coming down the pike, and I don't know how quickly this will happen, but we see this right here. Fires deprecation warnings for, I guess strict mode fires deprecation warnings for, but here, deprecate component will mount, component will update, and component will receive props even outside strict mode. So 16.4 is going to deprecate these methods, and they're going to keep them working, but with a warning, so they can be prefixed with this unsafe tag to keep using them. So if you have an application out there and you're using this all over the place, you can just go through with your find and replace across your project and tag them all with unsafe and upgrade, and that can be part of your upgrade process when 16.4 comes. So 16.3 is going to start firing warnings. 16.4 is actually going to deprecate them, and then it says a far future major version, so that would be 17, or I guess 18. I guess 17 could be a far future, depending on how long it takes to get there, but it'd probably be a year or two. So I guess that can be considered a far future in tech time. We're going to remove the deprecated APIs. So those three are going to be gone eventually. So, excuse me. Oh. So that's just something that's going on right now. It's kind of just coming to the forefront of people seeing it and knowing that it's coming. They're not firing warnings right now, so it's not visibly out there. It's just people have picked this up in these issue notes and have started to talk about it a little bit. And the idea behind it is that, excuse me, these lifecycle methods could be potentially unsafe in an asynchronous world. So as async and await are getting pushed into JavaScript and more people are using them, and the whole idea of promises and how it's all working together, these lifecycle methods have been found to be unsafe in the way they can be used. I'm not 100% sure about how that is unsafe. I haven't delved deep enough into that and how that could happen. I haven't, particularly found those, examples, but that's what I've read about why this is happening. So the idea is that we want to move most of the logic that was previously implemented in these methods to either a component did or into the render method itself. So that's something that is coming down the pike. It's, kind of Facebook's move fast and break things, how they have been, known to do things internally with Facebook, are, applying it a little bit to their open source project, which is React. So that's just something that's happening. I wanted to tell everybody so they're aware of it. It's kind of cool to know about these things early, and they don't catch you by surprise when they happen. And you can talk about it like, hey, I was reading, the release notes for future versions of React, and I realized these things were changing. Do you have a plan for that? If maybe you're interviewing for a job with React, and you can bring that up and probably make you sound smart, or at least separate you from some other people who are interviewing for the job. So just wanted to start with that so that everybody...
Yes, I have a question.
Yes.
If you think they're not going to be having this, so I don't think so it's a good idea for us implementing them in our final project.
You can attempt not to implement them if you don't feel like you should. However, they're not going to be changing for a while. So 16.3 is not out, and that's just the warning. 16.4 is probably, I'd say, let's see. Let's look at, or I guess we can look here. Let's look at the code. 85 releases. All right, 16.2 was in November. 16 point, that's a minor. 16.1 was in November. 16. Where's 16? 16 was back in September, I think. Yeah, so 16 came out in September. So whoops, wrong page. 16.1 was 2 months later. 16.2 was still there. Alphas are out. They said they're not going to completely remove it for at least until 17. And if I remember right, that's going to be at least a year or two. And since they are not even throwing warnings right now, they're being used all over the place. So my personal recommendation would be that you should implement them in your project, because knowing how to utilize them is what is going to be out in code right now. Okay. So you're going to, if you don't dive deep into how to utilize them now, if you go to a job that has React, they're going to be using it, because it's not even near being a breaking change. And that might be something that they choose not to upgrade to when 17 comes along in a year or two. Like I was working less than a year ago with a production app out there, and it was using Rails 4.2. Like the cycle of things getting upgraded is, I think, a lot slower, because once things are in production and you have a lot of code, it takes a lot more work to move from version to version. Yeah. So I don't think these things are going anywhere anytime soon in a lot of production apps. It's just too much to refactor out and change. Okay. So it'll be one of those things that, unless there's a really big compelling reason for people to move to 17, if they have these all over the place, then it might be something that, they put off for a while. But yeah, good question. Good thought. So the component lifecycle. I found this image. I think it's pretty cool. And it kind of covers, well, doesn't kind of, it does cover the whole component lifecycle as it stands. Where's my other notes? Somewhere in here. Cool. So the life cycle of a component can be defined as the time from when the component is first being inserted into the DOM, the entire time the component is in the DOM, and the point where the component is being removed from the DOM. And there's a unique life cycle for every React component in our code, which is what makes it, kind of awesome to have little pieces of the page as their own React components, because they all go through these lifecycle methods independently. So you can have all types of different things. I mean, Facebook is a great example of that. I know not everybody's on Facebook these days. I know some people who aren't. So, but there's a little chat thing that's updating in one place. There's your feed in the middle that's updating independently. There's all these different little pieces that update on their own as things are changing behind the scenes. And that's really one of the really cool things about the React style of things. React's not the only library or framework that does that, of course, but it's one of the things that really set React apart, this idea of components. And you build this one little area to do exactly what you need, and it can do its thing on its own while you're taking care of another section doing its thing on its own, and so forth and so on. So the overview of our lifecycle is, the lifecycle methods are hooks to allow us to read state changes and control UI updates. So it can really be broken down into three major sections. We have mounting, and that is when the component is being added to the DOM. Updates, and that's when the component receives changes to props or state, and is called when the component is being re-rendered. And then unmounting, and that's when the component is being removed from the DOM. And lifecycle methods provide entry points into these times to take over any of these steps. So any method that begins with component will be accessed before the event occurs, and any method prepended with component did means you capture it after the event occurs. So we have 4 methods in our mounting, and that's our constructor, our component will mount, our render, and our component did mount. And we have this little extra box about server rendering, which is something that this component will is going to disappear and make server rendering have to happen differently, and I'm sure people will figure that out. For updating, we have our component will receive props. We have our should component update. We have our component will update. We have our render, once again. We have our component did update. And then lastly, with unmounting, we have component will unmount. So we're going to walk through all of these, some, and yeah, stop me if there's any questions, comments, thoughts, ideas, want to dive deeper into something, and we'll go. So the constructor, we'll start with our constructor. And this method is called when the component is being created and before mounting being added to the DOM. So its primary use is to initialize state and to bind this for components methods. If you do neither of these, then there is no need for a constructor. And typically, if you're not doing either of those things, you can probably, I don't know, maybe, probably, depending on your use case, build it as a stateless functional component. Because if you're not setting state, well, setting initial state, I guess. So no, you still need to initialize state. So if you don't have the constructor, most likely have that. So I'm not going to dive into like the code as much unless you guys want to. I guess some other people joined us as we went. So if anybody feels like they want to see examples of these things, let me know. But from my quick survey at the beginning, everybody was feeling pretty comfortable with these methods. So I don't know that showing, class, component, extends, component, constructor, props, super props, this.state equals type of thing is necessary in this context. I think there's some good examples of it in the curriculum. But like I said, if you feel like you want to see any of that, please just let me know, because I'm making an assumption. So next, after our constructor, we've initialized some state. We've bound this if we're choosing to do it there instead of binding it using arrow functions in either the function or in the call in the render. We get to component will mount. And this method is executed right before a component is added to the DOM. So it's added to the DOM and render, as we see in our flowchart. So it is generally recommended to use the constructor, but this method is still included in the API, mostly for backwards compatibility. So that's also, I think, why it's starting to work down the process of deprecation, because it's not recommended use anymore. The constructor is where it's recommended to do these things. So it's just kind of fallen out of favor, so to speak. And something to be wary of is you should avoid calling any functions that cause side effects in this method, as set state won't trigger a change and there is no DOM to interact with. So at this point, this lifecycle method won't trigger like we don't set state in ComponentWillMount. And because of that, it can't actually do things, like side effects being, if we change state inside ComponentWillMount, we're not going to get a re-render. So it's not going to cause changes to be visible in our DOM. Something of note is this is the only lifecycle method that is called on the server if you're doing that type of rendering. So after ComponentWillMount, we get our render where everything is being converted from our JSX into our HTML, CSS, well, not our CSS, but we get our HTML in the browser render so we can see it. So following our chart, we hit ComponentDidMount. So now our component has been rendered and exists in the DOM. This is the point when we should be initiating AJAX requests, adding event listeners, and performing any setup that requires a DOM. So also, from this point forward, inclusive of this point, calling setState will cause a re-render. So after we hit after this initial render, anytime we call setState is going to cause a re-render. Now, I know a use case where I've seen this ComponentWillMount is doing those AJAX calls. So because it should come back, it should feel like it comes back a little bit quicker. So let's say, because we're sending it off, if we're waiting on a promise to come back, we can asynchronously call a fetch, and then the code's going to keep moving on and render while this is waiting for it to come back and do its thing. However, since we're not calling side effects in here, we should be doing that here, ComponentDidMount. It might seem like it should be in ComponentWillMount, but ComponentDidMount is where we put it. And that's why React apps all over the place these days have kind of brought back into the web the loading spinner. A big name or quote unquote big name in the React world is Donovan. I can't remember his last name. I was thinking a different Donovan that I know, but the guy's name is Donovan. And he's the head of engineering for American Express. So American Express is a React app now. Their whole dashboard, if you have an American Express card and you log in, it's React. And every little piece of that page, when you log in, your account stuff, is a little React component. And when you log in, all you see are these little circles spinning because it's loading. And that's because it made a call to the back end and it's waiting for the information to come back. So yeah, that's something that I think we, as web developers, well, I guess I wasn't part of that time, but web developers, I think in general, went from a time when internet was slow and we had to have loading bars everywhere because things, media got rich, but the bandwidth didn't keep up. Then media caught up and everything was quick and there weren't any loading bars anymore. And now with the way we're doing things, we've kind of brought them back because we can't render things without data. And that's kind of interesting. But yeah. So, excuse me. Next up, we get to component will receive props. And we'll follow these arrows kind of, but some of them are circular. This is a life cycle, so it spins. So we'll follow it around a little bit. So component will receive props. Our app's running, props changed, and then we get this component will receive props lifecycle. So this is triggered when the component receives new props from its parent. And this is a great time to check if there are changes in the incoming props when compared to your current props and trigger a state change based on the new values. So a common use case for this is resetting state based on a change. This could be a good one to show. If I can. Just open up Apple. So component will receive props. And that receives the next props. Figured it would yell about stuff. Then something like if this dot props.id is not equal to next props.id, and this set state, let's say content back to nothing. So this is a popular place to do things like this. So, you know, if there's something on the page based on props from the parent, then we get new props we want to check and say, you know, maybe we have a list of articles that are rendered based on the selection of something in a parent component. You know, we could have a sidebar or something that's a parent component that has categories. And when you click it, it re-renders stuff in the middle, you know, a list of contents. So we might want to reset it to blank and probably get a little loading spinner again and go from there. This is a good place to do stuff like this. After that, we hit should component update. And this method actually exists purely for performance improvements. So renders and reconciliation are expensive in React. I won't dive too deep into those, but there is reconciliation is in the React docs. It's in the advanced guides. So if you want to dive down into that some, you can. But renders being, you know, redrawing stuff on the page is probably the slowest thing that React does. I guess in my mind, I believe that is. I can't say that I know that for sure. But there are ways to speed this up and, you know, decide should renders happen and such. So should component update receives two arguments. It receives next props and next state, as we see here. And it provides the developer the ability to return a Boolean, true or false, from this method, which controls whether React should perform the reconciliation operations, but really all that I've ever thought about is the DOM updates. Should it redraw? Should it re-render? So the default behavior is for React to render every update, which works in most cases. And React is super smart, so diving too deep into should component update can actually hurt us, but it can help us sometimes. If should component update actually returns false, then component will update, which we see down here, render, and component did update will not be invoked. So we actually skip this section. If this is false, we go right back to just leaving our app as it is. So there are ways to utilize this. I've done it before. Let me think. So let's say should component update. Oh, key combination, do not want to do that. Next props and next state. We could say something like return, because we want to return a Boolean, true or false, and say like this.props.clicks not equal to next dot props dot clicks, or whatever we might want to include there. And this can be implemented as a performance enhancement, but doing it everywhere can actually be detrimental to us. So something that React talks about in the docs, components, can't ever find everything. Is this React? So there's this React Pure component that I learned about at one point in time and was like, whoa, why didn't I learn about this? Why didn't I use this? It's similar to React component. The difference between them is that React component doesn't implement should component update. So basically it's skipping this should component update. It's saying false and just going there. So wait, React component doesn't implement, but React Pure component implements it with a shallow prop and state comparison. React component doesn't unless we explicitly implement it. It just says true all the time. And then Pure component implements it with a shallow prop and state comparison. That's what it is. So you can say, you know, this does it automatically where it compares current state to next state and current props to next props. And if they don't update, if they're not different, it says, okay, let's not re-render. That can cause issues. So knowing where to use this is key, but it is something useful and something that I don't think everybody knows about. So that should component update. You're telling your component, should it update or not? Should it re-render? Should it do that reconciliation step? And that can make things quicker. So if it's going to update, if we're not touching this, and you know, React by default says true, we're going to get to ComponentWillMount. And React invokes this method immediately before rendering when new props or state are being received. So there's not much use for ComponentWillMount with the next props in the next state and should probably be avoided at this point in time. We should be able to get everything done that we need through our other methods, our other lifecycle methods. Something that we shouldn't be sure we shouldn't do is we shouldn't do anything that will change the state at this point. We should follow and change state, and a component will receive props if we need to do anything before the render. So we have these three lifecycle methods that are before the render. And if we want to change anything in the state, this is where we want to do it. ComponentWillMount is also not called on the initial render. So now immediately after React builds a shiny new UI, it's, you know, we've given it new props and it says, oh, things have changed, time to update, and it renders. Updates everything and renders. We get this component did update, and that gives us the previous props in the previous state. And this is a great time to interact with the DOM or instantiate a new network request based on what the new interface should look like. So if we think about things that happen in component did mount type of time, we have component did update. So this is kind of like the first one, and this is the ongoing one. Component did update versus component did mount, because we're not going to get component did mount anymore, but we're going to get component did update. Then finally, if we come to unmount time, we have this component will unmount. And this is when it's time for us to get the component out of the UI. This is where we clean up everything that was associated with the adding and maintaining of the component and clean up after ourselves. I have to say, I haven't used this much. But some use cases where I think it could be used, or an example where it could be used is something like component will mount. Let's say like window dot remove event listener. So if we had attached an event listener, we're going to want to remove it when our component is taken off. So if we're adding things to the DOM, we're adding event listeners and such, we want to get rid of those so that they're not still sitting out there waiting when the actual thing that's going to use them isn't even there anymore. So really cleaning up after ourselves, things that we've put out there and are quote unquote living at this point in time. And they need to go with us when we leave. Now, there is one more component lifecycle method that was added in React 16, and that is not included in here. And it is component did catch. And that is two things, not error, and info. So this is a new lifecycle method that was added in React 16, and you can look it up. It was, if you look up, new things in React 16, it's pretty much mentioned in any of those videos or posts. I think Dan Abramov does a quick overview of the new things, or somebody from the React team does somewhere. But yeah, it's out there. It's easy to find if you Google. But React was notorious, and if you've been building things in React, as I'm assuming you have somewhat at this point, or you will be if you haven't yet, you'll see that it's notorious for crashing the entire application. Just one error, if a JavaScript error was thrown inside the React app anywhere. So you might have one component that has a JavaScript error and nothing shows up for the entire React app. It's just all dead. And that was a big pain because, you might be working on one little component or there's an error in one little place and nothing works. So what was happening is it was corrupting React's internal state, which pretty much blew up the app and yielded some cryptic error messages. We don't see them as much because of the build tools that we're using. We get pretty solid errors that are pointing us in the right location, but still something out in production, you don't want that to happen. You don't want the entire app to go down because of one JavaScript error. So component did catch is implemented to solve this problem by catching any JavaScript error occurring in a component's tree for the children of the component that implements this method. So if we implement this method on a parent, it'll catch any error in all of the children. And then it's also able to display a fallback UI. So kind of like the classic 404 page, when there's an error, you have something, you put it on your server and say, hey, when there's an error and you can't show anything, you show this page. So now there's this component did catch that you can implement. And I'm trying to remember, there is one kind of gotcha about it. I just don't have here in my notes. And I'll show how a good way to, or kind of a, maybe not good way, but an example way of implementing it. But it is suggested that you don't use this to wrap like your entire app. Blanking on why right now. I bet I have it in my notes somewhere. I'll find it. Let's go through a real quick example of what this might look like. So something that people are doing these days is creating this error boundary component. So let's say we're not React. You'll see something more like this. This is obviously not going to, REPL's not going to understand this right now. That's fine. Okay, so you have a constructor with some props. And then you have a super with props as well. Let me say it like this. State equals has error false. And we have our component. Oh. There. Component did catch error info. And then right here, we have something that'll set our state, change our state. Let's say, has error, set that to true. If we hit this component did catch, then we hit an error. And then we have the info. So can also log the error to error reporting. So if we're working on apps in production, you're typically going to have some sort of error reporting system, and you'll send errors to it, and you'll have some dashboard somewhere probably where you can see all the errors, and sometimes you have thousands of them, and you're just like, oh, that's one that we haven't fixed yet. It's okay. So log error to error service. We'll take the error and the info and send it off on its way. And let's see, then we'll have render. Let me say if this state has error. And here we can render anything. It's our render. So we could say, return just oops, something went wrong. Is that face? Yep. Return stop props dot children. And then after we wrote something like this, we'd implement it around components. So the error boundary. Error boundary. So what we're saying is, we create a component, and okay, catches an error. So we change this has error to true, we log the error, then we render our error. If we don't hit this error, so this has error stays false, then we're going to return the children. So we're going to return whatever's in between, inside that, the children of that component, and just render like normal. And that's pretty straightforward way to implement this pattern. So if you're using React 16, which I believe if you're just using Create React App on your project, you will be, if I remember right. I think the curriculum's updated to 16. Last time I forget to look at the actual versions in the package .jsons of what's going on, but I think they are because there weren't many breaking changes from 15 to 16. And this is something that you might think about implementing around a component or two. But look it up and get to understand it a little bit better. Look up why not to, we'll look it up right now. Wrap entire app in component did catch. That's talking about it. This is implementation of it. This is teaching it. Why do I need? Benefits, issues. When should I use? You can wrap your top-level route components. You might also wrap components that might contain obscure code. It is up to you how to best handle protecting against application crashes. More standards and best practices. There's something that it does. I think it has to do with async stuff, that if they don't return properly or something, we don't get. Oh, error boundaries do not catch errors for event handlers, asynchronous code. That's what it is. So if you have an error in your asynchronous code, it's not going to catch it. That's what it is. I knew there was something that a gotcha in it. So that's good to know. Your app might still be crashing and failing, and you're like, but I wrapped it all in an error boundary. Why can't, what's going on? Oh, look, this is the exact example that we were just looking at from the docs. There's another, you guys can look into it deeper. There's a way to implement like a try catch with an error handler like this. And then you can catch those other errors that it doesn't catch. The error boundary won't catch. And then you can kind of catch all errors, which is cool. I've seen it one time. I don't have an example of it right off the bat. I should save it somewhere, the pattern, because it's very useful. I used to have all these code snippets and I lost them. So yeah, but yeah, that's not home. That's the entire component lifecycle method, including component did catch, which is new, you know, less than 6 months, well, September, I guess 6 months old right about now. So yeah, questions, comments, discussion. I feel like I've been talking forever. Okay, well, if there's no questions or comments, then say thank you so much for coming out tonight and hanging out, spending some time with me.